Okay, good morning, everyone. So what we're doing today is going into graphing parabolas. We're not really going to solve for them. We're just going to look at the structure, and from that structure, we can graph it. So very similar to our absolute value graphs, if we understand what the structure looks like of the equation, we can then graph it really quickly. So let's first talk about what a parabola is. A parabola is the graph that looks like this U shape. It is not sharp, it is always curved. And also, it is following always an x squared f of x, or you could call this y, right? It's some type of x squared problem. Okay, it's not x cubed. It's not just x by itself. It is always leading with an x squared. So if you see f of x is equal to something with an x problem by itself, this is always going to be a line. If I see f of x is x cubed, we get this serpent. It goes like something like that, some type of form. So x squared goes from a line to this serpent thing, from x to x cubed. So x squared is right in the middle. So we have this one serpent thing going. Well, I mean this u thing. Now let's really quickly look at y. It looks like a u. If I give you an x and y table, we'll put 0 right in the middle. And what is 0 squared? It's just 0, right? What if I put in 1? What is 1 squared? That's just 1. And 2 squared? 2 squared is actually not 2, but now 4. So you see this progressive jump. We go from 0 to 1. Seems not like a big deal, right? And then once we take one step over, instead of going one step up to form a line, we actually end up taking 4 steps up. So you end up, so if I just draw a line, I would have missed it. So we have to start doing a curve. On my left side, oh, okay, just do one more. If I do one more step, 3 squared is 9. Wait, we went from 1 step to 3 steps to all of a sudden 5 steps. If I take one more step, we jump up to 16. So that square actually does a big number on my results. Imagine if this was your savings. You go from a saving of $1 to $3 to $5 extra to all of a sudden $7 extra. Okay? So it increases very quickly. And that's what the great thing about squares do. They're not lines anymore. They form this curve, really quick curve. All right, going on the left side, let's do -1 on top. Now, here's the thing about x squared. Whenever you square a number, it becomes positive. Whenever you square a number, this -2 becomes positive. Now, if you notice that these values start to repeat, because when you square a number, it becomes positive. It's still squared, but it also becomes positive. So we get this image reflection across our x-axis. Sorry, our y-axis. I'm sorry, y-axis. Here's -1, -2. Put 1, and then put down 4. And we end up with this parabola. Okay, so great. We know what the basic shape. This is what we call the parent function. Parent function of x squared. Okay, so like we did for lines and we did for absolute value graphs, there's a structure to these. For lines, it's y equals to mx plus b. So if you know what your slope is and where to start your y-intercept, we were able to graph these pretty quickly. If I wrote y is equal to 1/2 x plus 2, we start off at 1, 2, put a dot, and we just follow the rules. Rise, 1, run, 2. We have a line. For absolute values, we had y is equal to a, x minus h plus k. So if I write y goes to 1/2, x minus 1 plus 2, our vertex was h comma k. And in this case, it's not -1, but +1 because the negative is already there, right? The negative was already there. So h is 1 and k has to be 2. And we have our a value is 1/2, which is essentially our slope of the line. I'm going to graph this on my left. So at 1 up 2, we can graph the slope up 1 over 2 spaces. And that was our slope to our right. Remember, absolute value graphs were also V graphs. So if I go up 1 to the right, I'm going to go 2 to the left now. 1, 2. Okay, and we did a lot of graphing problems like this already. Hopefully you guys are very quick at this now, once you see it in this form. Now, parabolas now have their own form. This is our vertex form. So our parabolas have this vertex form. And this looks almost identical to this when we did absolute values. So we're going to say y is equal to a, absolute value, nope, not absolute value, I'm just copying absolute values, parentheses, x minus h squared plus k, where the vertex is h comma k. Now the a value is going to give us some easy hints to some easy level 1 graphs. But as we kick up a notch, as a becomes 2, 3, 4, or even a fraction, that's going to change our outcome of the graph. And it's not going to be as predictable till we figure out how to read it. Once we learn how to read it, super easy again. Okay, but we have to learn how to accommodate, especially when it's a fraction. Okay, so here is our first example. Y is equal to 1. Let's call this a 1. Not going to write it. X squared plus 2. Okay, this can probably be written as y is equal to x squared plus 2. Okay, if I drew the parentheses there, I want you guys to key on that. First thing, there is no, in a regular parabola, oftentimes you see this x squared plus 3x plus 2. When in vertex form, you don't have x by itself. This is not here, not here. Okay, so our vertex forms have to say that we have an x squared and a number, only x squared and a number. There's no x in this. There's no regular x in this. Only x squares and constants. Okay, that's our pattern for these vertex forms. So if we do have this pattern, let me ask you, what is your h value and what is your k value? Okay. Hopefully you are saying h is going to be 0 and k is 2. And to rewrite this, it's really x minus 0 squared plus 2. Right? X minus 0 is 0. So we don't have to see a 0. We can assume that there's one there. We can put it in there because the 0 doesn't affect the problem. Now, why is this so kind of cool? It's because it follows the same pattern as our parent function in the back. We said the parent function went 1 step over, right? 1 step up, 2 steps over. 2 squared is 1, 2, 3, 4 steps up. 3 steps over, 3 squared is 1, 2, 3, 4, 5, and going all the way up to 9. Okay, so that's actually our same pattern that we're going to see. Let's see if we can discover that. If I plug in the vertex, x is 0, y is 2. Okay, so I'm going to create a quick t-table, and this is probably one of the only times I want to do this for these problems now. My vertex, my center of my graph is at x is 0. This is what we call this is the center, right? But this is also the line of reflection. X is equal to 2 because at the center of the graph, x is 0, the right and left side are going to look exactly the same. And let me demonstrate that. X0, let's pick a number on the right, a number on the left, a number on the right, and a number on the left. If I plug in 0, it would be 0 squared plus 2, 1 squared plus 2, 2 squared plus 2, negative 1 squared plus 2, negative 2 squared plus 2. I'm plugging in this y equation to fill out this graph. Okay. You could plug in 0 here, and then 1, and then 2, and then you just run out of space. So just create a quick table. So 0 squared is 0, plus 2 is 2. 1 squared is 1, plus 2 is 3. 2 squared plus 2 is 4, plus 2 is 6. And going the other way, it's just going to repeat the same numbers. Now, I want to show you the pattern for these basic parabolas with an a value equals to 1. So with a equals to 1, here's the idea of the steps. So 1 step means 1 squared. 2 steps mean 2 squared. 3 steps means 3 steps. So 3 squared. So it's 9 steps. So this is up, up, up. So 1 step over, 1 step up. 2 steps over, we said 2 squared is 1, 2, 3, 4 steps up. Oops, miscounted that. 1, 2, 3, 4. 1 step over to my left, 1 squared is 1 step up. 2 steps over, 2 squared is 1, 2, 3, 4 steps up. That's a pattern for all our x squared graphs, because essentially you are squaring whatever number you're plugging it in. So if I step 1 step over from my vertex, 1 squared is 1 step up. Then we add 2 to it. So look here, we take 1 step over in the x direction, we took 1 step up. 2 steps over, 2 squared is 4, 4 steps up. 1 step over, we took 1 step up. 2 steps over, we took 4 steps up. Now, to graph this on IXL, let me get there real quick. You guys are going to be graphing these on the Algebra 1 version of this course. So the vertex we said, we'll just use this as an example. 0, 2, put a dot. We said 1 step over, 1 step up. That's your parabola. 2 steps over, 1, 2, 1, 2, 3, 4 steps up. Will be exactly the same graph. If you notice right here, oops. If you notice right there, it's still 1 step over, 1 step up. 2 steps over, 4 steps up. 3 steps over, it should be 9 steps up here. So the cool thing about using IXL, you really only have to graph one more point. So 1 step over, oops, 1 step up. That's our basic parabola with the a value of 1. Now, let's change this a little bit. Let's give ourselves another example. Y is equal to 1, let's do 2. X plus 1 squared minus 2. Help me find the vertex of this graph. Please tell me what my h and k would be. It should be negative 1, negative 2. Negative 1, negative 2. Why? Because remember, it's x minus h squared plus k. So we always do the opposite number. Cool. So we're at negative 1, negative 2, and then we're down 2 spaces. Now, in this case, the a value is not a fraction, it's a whole number. So I want to kind of show you just with one step, what would happen with that 2? What does that do to the problem? So let's do our x and y real quick. We know the vertex is at -1. So that's my center of my graph. And we know we're going to get our y value -2. But what happens if I take a whoops, I misgraphed that one. What happens if I take one step off from this? Going one step over, like we talked about before. One step over would be -2. Whoops. Yeah, -2. And what happens at -2? Let's write it. 2 parentheses -2 plus 1 squared minus 2. I want you to notice specifically what happens in the parentheses. What happens in the parentheses? -2 plus 1 is -1. We're back to a -1 squared. So it's really, in essence, one step away from my vertex, right? We said, how far is -1 from -2? Well, that's one step away. That's one step away. And normally for a parabola, we would go one step up. And that kind of is reflected here because -1 squared is really just one step away. But there's a modifier here. This a value changes how fast I'm growing. Imagine if I said, I'm going to double your speed, right? So you do everything twice as fast. And that's what this 2 does. It says, hey, I'm going to multiply your speed by 2. So this graph, as we mentioned before, stretches in a vertical manner. So this graph, which would have started taking off its time, taking its leisurely time for a parabola, is now going to be twice as fast like a rocket. Because for every step I take, I'm going to be twice as fast. So for a regular graph, one step over, one step up, 2 steps over, 4 steps up, I'm going to double all my answers. One step over, 2 steps up. 2 steps over should have been 4. Now 8 steps up. 3 steps over should be 9. 3 squared is 9. But then double that. 18 steps up. And this shows us, let's go ahead and finish this, it'll be 0. And when x is -2, my y value is 0 because one step over usually is one step up, but now multiplied by that front number is 2 steps up. So one step over should have been one step up, right? It should be here. But since we multiplied by 2, we end up doubling our value. 2 steps over should have been 1, 2, 3, 4. That's our parent function. But since we're double the speed here, we go 8 steps up. 5, 6, 7, 8. So if you look at the parabola here, it is a lot faster. So we'll do the right side now. Work with me on the right side. One step over for regular parabola is usually one step up. We should be here. That's where we should have been. We should have been here. But since you are times 2, we are 2 steps up. 2 steps over should have been 1, 2, 3, 4. But since this is a times 2 parabola, twice the speed, 2 times 4 is now 8 steps up. 4, 5, 6, 7, 8. So we end up with this super fast parabola. Okay, so we end up with this super fast parabola. Now this works really well with whole numbers. Honestly, this works really well with whole numbers. And if we were graphing by hand, this works really well with fractions too. Now, this last part, I need to show you guys the fault of this next part. If I write y is equal to 1/2 x plus 1 squared minus 2, okay? Now we change that to 1/2. So ideally is that the concept is, imagine if I multiplied your paycheck by half. If I multiplied your height by half. If I multiplied, what else? Your grade by half. So instead of going up in a nice progressive manner, if a half, doesn't that slow your graph down? That's going to slow your graph down. Now, give me a sec. I'm going to show you this. Okay, so just to show you this example, we have x squared right in the middle in the color black. And then we're going to change our a value. So if a value was not 0, exactly 1, would be exactly the same graph, 1x squared. If I make this 2, like we mentioned before, 2, the graph becomes skinnier. It becomes faster. Now let me show you the point here. If I take one step over, should be one step up. But since there's a 2 in front now, 2x squared, we're up here, 2 steps up. 2 steps over should have been 1, 2, 3, 4, but now we are 5, 6, 7, 8 steps up. So it follows a pattern like we said before, 1 step over, 2 steps up, 2 steps over, 8 steps up. Why? Because we're multiplying all our y answers of our parent graph by 2 now. 3 steps over, 3 squared should be 9, but now we multiply by 2, that's 18. Now, what if I half step this? Okay, what if it was 1/2 x squared? 1/2 x squared. If you look at our dotted line here, it is slower to grow. If I move this even lower, nope, I can't do that. If I move this even lower to be 1.5, sorry, 0.25, which is 1/4, I'm even slower. And if you actually put at 0, it makes it a flat line. Because if you have 0 x squares, no x squares means you're just left with x, and that's just a line. Okay? So if I wrote 1/4, I'll show you something kind of cool. Look at the one step over. Look at the one step over here. It does not look like a quarter of the way up. Let me zoom in for that. Zoom in for you. One step over is over here. Here's one step over. Does that look like, what is this? That's supposed to be 0.25, right? 0.25, 0.30, 0.35, 0.4. That's 0.25. So if you're graphing this by hand, if there's a 1/4 in front, one step over would just mean 1/4 up. If it was a 1/3, it would be 1/3 up. This is probably a better view of it. One step over is 0.25 up. What if I wrote 1/2? One step over would be 1/2 up. 0.75. One step over would be 0.75 up. Right here, look at this point right here. Right, that's one step over is 0.75, right? So one crazy cool mechanic of that is that when you're graphing these graphing parabolas, if you have this in this vertex form, you can graph these graphs in manner of seconds. If I say, let me finish graphing this one. This is -1 down 2. My h and k, my vertex is -1, -2, -1, -2. And my a value is 1/2. So one step over, half step up, not a full step. Two steps over should have been 4 steps up, right? 4 steps up. But what is half of 4? 1, 2 steps up. If I go 3 steps over, 1, 2, 3 steps over now. 3 steps over should have been 9, but half of 9 is 4.5. 1, 2, 3, 4, and a half. We end up with this parabola here. 1 step over, half step up. 2 steps over should have been 4, but half of that is 2. 3 steps over should have been 9. Half of that, right? This is half of it, should have been 4.5. So if we can understand how to graph these using this formula, graphing parabolas is actually just as easy as graphing absolute values. Now the only thing now is, what if a was less than 0? What if a is negative? Well, if it's negative, actually, Turns out, not a big deal. If a was negative, it would just flip the graph upside down. Y is equal to negative 2x squared plus 1. Be careful, what's my vertex here? I wrote this for a reason. My vertex is, do we have an h value? No. My k value is 1. So at 0, positive 1, double check, make sure you have your x's and y's correct. For the homework, you just have to make sure you understand what you're doing, because IXL, you're just gonna graph it really quickly on IXL. So we're gonna go one step over. Usually it's one step up. But what is 1 times negative 2? That's gonna give us negative 2 steps down. If I go 2 steps over, should have been positive 4. But 4 times negative 2 is negative 8. So negative from the vertex, 1, 2, 3, 4, 5, 6, 7, 8. So this graph is pretty fast dropping. So a couple of hints. If it's positive, we know for sure it's going up. If you see x squared and there's a positive number in front, for sure it is facing up. If you see a negative, it is going to face downward. And that's why we use the word face. This is facing downward. Oops. Okay, all right. So the last part here is when you're graphing your IXL, there is a problem with graphing in IXL. When you're graphing in IXL, if I write 1 over 2 x squared, in IXL, we mentioned before, if the vertex is 0, 0, so my vertex is 0, 0, but the a value is 1/2. So one step over would mean a half step up. And IXL can do half steps. IXL, half steps. Okay, no problem. We can do half steps. But IXL cannot do any other steps besides half steps. If you give me a quarter step or a third step, IXL, you cannot graph it easily, like the method I taught you just now. So hand graphing is always the easiest. But in IXL, you cannot do that. Okay, so let me show you what happened in IXL. If I'm trying to graph y is equal to 1 over 4x squared, it will not allow me to do it. So the graph would be one space over, and it would be a quarter of the space up, right? It's pretty small, a quarter of the space up, quarter of the space up, a lot more flat. But let me show you what happens in IXL. If I try graphing this in IXL, 0, 0, and if you take a look here, whoops. If you look here, I can only graph half points. So if I try graphing 1/4 x squared, it would actually give me the wrong answer. Hello? Okay, you'll see problems. As the problems get harder, you'll start seeing these fractions of 1/3 or 1/4. Okay? And then you can graph it using this easy method. You have to find another point. Now, if you look here, you'll see that, hey, isn't 2, 2 a nice point, nice whole number? These are the points you're going to have to look for. Now, here is the gimmick. Let me say this, it's really a gimmick about graphing these. So if I see y is equal to 1 over 4 x squared, let me ask you, what would x have to be to cancel out the fraction 4? What number are you looking for to cancel out a fraction 4? Aren't you looking for the number 4? Could you make x a number that would darn it, I'm keep getting kicked out. Can you think of a number that would make x become 4? You could use the number 2, right? So if I plug in, oops, This one should have been, we said we couldn't graph 1/4, right? We couldn't graph 1/4. So this graph is actually, oops, come on, go away. This graph is going to be, let me show you. So what value can I plug in here to make the problem easy? Plug in 2. So if I plug in x is 2, so we have 1/4 times 2 squared is 1/4 times 4 is 1. So when x is 2, y is 1. And that's what I want you to do. Graph the second point at 2, 1. Now go back and look here. If you look at the quarter mark, whoops, come on, go back. Look right here. Isn't 1 space over 1/4 the space up? 1 space over 1/4, and it matches my original way of graphing these. The problem is IXL, you cannot graph 1/4, right? I can't put a dot here. I can only put a dot at 1/2. So you have to find the next easiest point. And the way we do that is trying to make this a whole number. Now, let's go ahead and take a look at some problems that this will be applied for. So I'm going to jump to the highest problems here. And this is going to be a little tricky for you guys. Okay, these are all going to be easy. That's going to be, look, for this one, what's the vertex? +7, y is 0. So, and times 4, 1 step over should be 1 step up, but times 4, 4 steps up. Oops. That's what this graph is. This is x is 0, y is 10. So at 0, -10. Oh, 0, +10, I'm sorry. That's my vertex. H is 0, k is 10. And 1 step over, -5 steps down. 1, 2, 3, 4. Oops, these are double counts. Right there, 5. Oops, I miscounted 1 step. What else? Okay, so the problem is once we get to harder fraction problems, where a is a fraction, let me get there really quick, come on. Okay, so FYI, what is 7/2? 3.5. You can graph 3.5, okay? So if it's 3.5, -3.5 is about right here, and we want to go 3 steps down. Okay, that's my vertex. 3.5, -3.5, and -3. Now, to do this graph, a value is 1, right? So that's 1 step over, 1 step up. So from this fraction, we want to head 1 step over to the right, and then 1 step over. Let me do that again. 1/2 step over to the right, and then 1 step up. That's our parabola. This is the one I was referring to. This is the one that looks a little creepy. But it's actually still doable. Now let me tell you why. 2/3 x minus 3/2 squared minus 4. Here's what we said. What number can I use to get rid of 3? What number is squared? An easy number squared. 1 squared is 1. 2 squared is 4. 3 squared is 9. Doesn't 9 divide out 3? So I want you to actually just write 9 there. Okay, just write 9. What's 9 divided by 3? 3. So 3 times 2 is going to be -6. So what happens is we are going to move over 3 spaces because 3 squared is 9. So from our vertex, which is going to be 1/2, -4, 1/2, +1/2, -3/2, comma, -4. That's a +3/2. That's 1/2, -4. And we're going to go 1, 2, 3 steps over. And we said we're going to end up -6 steps down. 1, 2, 3, 4, 5, 6. Okay. 1, 2, 3 steps over. 1, 2, 3, 4, 5, 6. This one, what number could I use to cancel out with a 4? Is 2. So if I go 2 steps over, we would be 2 squared is 4, and that would cancel out. Let me write that again. So -3 over 4, x minus 2 squared plus 3 over 2. Okay? Don't worry about any of this stuff. What we're going to talk about is steps. First, let's find the vertex. The vertex is at +2. 1.5 spaces up. That's the vertex. Now, if I go 2 spaces to the right or 2 spaces to the left, that's the important part. Because what is 2 squared? 2 squared is 4. And doesn't 4 cancel out with this 4? And we're left with our change, which is -3. Now, how did I skip to just 2 steps? Well, if you plug in x equals to 4, isn't 4 minus 2 the 2 we wanted? And that's what we're saying. I could count, say, 4, but instead, I want you guys to just count 2 spaces. 1, 2 spaces. 2 squared is 4. Doesn't 4 cancel out with this 4? We're left with -3, -1, -2, -3. Through this last step, I need to get a cancel out of 4 here, because to graph on IXL, I need to cancel out that 4. So -1 over 4, x minus 1 is 11 over 2 squared plus 6. This is 5.5. So positive 5.5 is right here. And we're going 6 spaces up. And the parabola is going to be facing downward because of the negative. So what cancels out with a 4? I need a 2 squared. So we're going to take 2 steps to the right or to the left. 1, 2. And then we're going to go down 1. Right? Okay. Okay, hopefully this helps. The IXL assignment is online. And if you need to watch this over again, please watch the video on this last portion. I think that will be helpful.